All right, everybody. Hello, this is Mr. B or Mr. Baranek here. Today what we're going to do is we are going to factor polynomial functions. Specifically, we're going to factor into what we call quadratic form. So our first example is y to the fourth power minus 13y squared minus 48. So what I notice first is we've got 1, 2, 3 terms, which makes this a trinomial. It kind of is structured similarly to that of a quadratic, which we're more familiar and comfortable with, especially when it comes to factoring. The difference is my degree here is 4, in the middle it is 2. That is not how quadratics work. That is not what their exponents look like. So it's not quite the same, but we can get this into what we call quadratic form. So we can treat it like one, and then we can factor with the methods we're already familiar with. So the first method I'm going to show you to factor a polynomial in quadratic form is using substitution. So I'm going to want to get rid of these variables in each term and replace them with something that makes this look more like a quadratic. Well, how I think about this is my middle term, I really want to be something to the first power. So what I'm going to do is I'm going to set x equal to y squared. What that means is my middle term is going to be negative 3x, and then my constant stays the same. Even more so, if I were to square x, that means I'm really squaring y to the second. And if I square that, I get y to the fourth. So that means that I can substitute this in, and here we are, and it looks exactly like a quadratic because it is now that we substitute it. Now that we're in quadratic form, many of us are comfortable doing this, but we can go ahead and factor. There are a couple options here. You could use the guess and check method. You could use diamond math or the box method. I'm going to use diamond math here. So I need two numbers that multiply to my C value and add to my B. Well, I know that because I'm dealing with the quadratic, I should have two factors. Each one is going to start with an x. The reason that is if I were to multiply this back out, so instead of factoring, if I were to go backwards, I could FOIL this, and then when I multiply x and x, I get my first term up here, which is x squared. All right, now I need two numbers that multiply to a negative 48 and add to a negative 13. That's going to be a negative 16 and positive 3. So I can go ahead and plug those in. We're almost done, or at least we think so, but I started with y's originally, so I want to end up with y's. So I am going to replace my substitution again. I'm going to go backwards. Instead of an x, I'm going to put in a y squared for each binomial. Now, normally we think we're done, but we got to remember whenever we're factoring, after a factoring step, we need to remember to check our factors and see if they can be factored more. Now, if we look at this first binomial, we've got y squared minus 16. Those are both perfect squares, and we're subtracting them. So that means this is really going to be the difference of squares pattern. On the side here, the difference of squares factoring pattern is a squared minus b squared equals a plus b times a minus b. So what I need to do is think about, okay, what value squared is y squared? Well, first of all, that is y. So this is going to be able to get broken up into two parts. Now I need to know what number squared is 16. Hopefully we know that is 4. So I'm going to put a 4 in each and then a plus and a minus. We can't forget we still need our y squared plus 3 here. That doesn't just disappear. We got to bring it with us the entire way. And then I would check this one and see if it can be factored more, but it's not the difference of squares because we're adding. So we are actually finished here. My final factored form is y plus 4 times y minus 4 times y squared plus 3. Here's our next problem. 3p to the 8th plus 15p to the 5th plus 18p squared. This one's a little bit more complicated because we've got more numbers and we've got more variables. So we need to remember that whenever we are factoring, we always need to try to divide out a common term first. So we need to think about what multiplies into each term in our polynomial. 3, 15, and 18 are all multiples of 3. So I can divide a 3 out. Well, all of the terms also have at least p squared. So what I'm going to do is I'm going to divide each one by 3p squared so I can leave it on the outside here. I'll give myself a little bit more room. Well, 3p to the 8th divided by 3p squared is p to the 6th. 15p to the 5th divided by 3p squared is 5p to the 3rd. Plus 18p squared divided by 3p squared is going to give us a 6. Now we're kind of where the last one started in terms of this part of the polynomial. So we could use substitution. In this case, our substitution would be a variable is equal to p to the 3rd and be a little bit different. I'm going to show you a different method now. For this method, we can actually take our polynomial and we're going to use what we call an area model to represent what we are trying to factor. So the area of this square or rectangle is going to represent this polynomial. So that means when I multiply the length and the width, I should get out this. And that's kind of how factoring works. We're thinking of two things that multiply to give us something else, just like length times width is area. So the way I'm going to start is I'm going to take my first term and put it in the first top left box. All right, what I need to do is focus on this box first. What value, the length, if you will, times what value, the width, is going to give us p to the 6th. Now, we have different options. It could be p to the 4th and 2nd, or it could be 5 and 1, or it could be 2 and 4, or 3 and 3. So it's kind of hard to know, but the idea is when we do our area model, our diagonals here should combine to give us our middle term. Well, there's only one term in the middle, so that means they need to combine evenly. And the only way that works is if each of these has the same power. So it needs to be p to the 3rd and p to the 3rd. Now, I need to put my 6 in the bottom. I need two factors of 6 two numbers that multiply to 6 and add to 5. Those are going to be 3 and 2. So I'm going to put a positive 2 and a positive 3 there. It doesn't really matter which one goes where. And now I can fill in. My length times my width is going to be p to the 3rd times 2, or 2p to the 3rd. And then my length times my width is going to be 3p to the 3rd. And I just multiplied my length and my width. Now, if you notice, my two diagonals add together, and they do, in fact, give me 5p to the 3rd. So what that tells me is these are my factors. All right, we can't forget about that 3p to the 2nd we divided about earlier. Whenever we're factoring, we're breaking into pieces, so nothing should disappear. We always want to keep all the pieces together because we want our ending factored polynomial to be equivalent to our original. So I'm going to keep that there, but then I'm going to put my length and my width, or vice versa, and these are my factors. Just like before, I'm going to check and see, can these factors be factored more? Well, p to the 3rd is a cube, so we might think the sum and difference of cubes pattern. But both 2 and 3 are not cubes, so that means we can't use that pattern, and therefore, this is the factored version. 3p to the 2nd times p to the 3rd plus 2 times p to the 3rd plus 3. Now, for my final example here, I'll move this over. I will do both methods so you can kind of see what it looks like. I'll keep them side by side. So we are still going to divide out our GCF. So they're all even numbers, so I'll put a 2, and they all have at least x to the 4th. So what I'm doing is dividing each of these terms by 2x to the 4th. And then what I get out will stay inside my parentheses. This will be x to the 4th minus 4x to the 2nd minus 21. Now we're just like our other values where we could use substitution. Since I'm already using x's, I might change this to a u. What I'm going to do is set u equal to my x squared because then I can just write this as, and I guess I don't need the parentheses anymore because we'll come back to this part. I can rewrite this as u squared, because remember, u squared, well, u is x squared. X squared squared is x to the fourth, which is our first term. So I've got u squared minus 4 times u minus 21. And again, we could use our diamond math. I need two numbers that multiply to a negative 21 and add to a negative 4, negative 7, and positive 3. So this factors into u minus 7 and u plus 3. Final step is replace my variables originally, right? We started with x's. I should finish with x's. So I have x squared minus 7 times x squared plus 3. And let's not forget, we divide out 2x to the 4th, so that needs to stay with us the entire time. Last step, double check and see, can this factor more? Well, x squared is a perfect square, but 7 is not, so that doesn't work. And this one has a perfect square, but it's also adding, so we can't use the difference of squares pattern. This is our final answer. As promised, here's the box method we could do. So I'm going to go from this step. So we're going to replace this part here with the box method. So the box method, again, we put our first term in the first box, our last term in the last. So I need to think about what multiplies length and width to give me x to the fourth. Again, we could have x and x to the third, or x squared and x squared. But I remember that my diagonals here need to add to my middle term, which means they combine. So that means I need to have them have the same exponents. Now I just need those two numbers that are going to multiply to negative 21, but add to negative 4. And again, that is going to be a negative 7 and a positive 3, because I'll have a 3x squared, right? Length times width. And then over here, I'll have length times width, which is x squared times negative 7, or negative 7x squared. If I were to add these, I get my middle term. So again, I still have that 2x to the fourth that I factored out earlier. But now using the box method, here are my two factors. And as you can see, we got the same thing. So either method is totally fine with me. If you have any questions or concerns, please feel free to ask. I'm sure you could reach out to your teacher as well. As always, thank you for joining us. If you have any question or comments, please leave them below. Don't forget to like and subscribe, and I will see you all soon. Thanks.